For example 6, it asks us for the measure of angle A and the measure of angle B. As you can see from the picture, angle A and angle B are the acute angles, and C is my right angle. I know two sides, 4 and 1. If I wanted to, I could use the Pythagorean theorem to find the measure of BC. I'm not going to do that, though. Two sides is plenty of information to be able to do this problem. All right? I have to pick which one I want to find first. Doesn't matter which one. They're both the same difficulty level. I'm going to go with angle B. Okay, I pick one of my acute angles. I'm going to find angle B. Once I've established angle B is the angle I want to work with, I'm going to identify the opposite side as 1. My right angle is here, which means the hypotenuse is 4. And that tells me my adjacent side is what I don't know. All right. Now, once again with trigonometry, we've got 3 pieces, 1 angle, 2 sides. As I know 2 things, I can find the third thing. In this case, I'm working with angle B. I don't know that. I know the opposite measure is 1. I know the hypotenuse is 4. So I want to know one thing, and I know 2 things. So again, that's the requirement to be able to use trigonometry to find something. I go again to SOHCAHTOA. I always start there to figure things out. All right, so if I'm working with the opposite measure, which is here or here, and the hypotenuse, which is here and here, only one thing, no good. Only one thing, no good. 2 things, perfect. So that's the one I need to work with. And I'm going to write out a good trigonometric expression. S for sine, so sine of the acute angle we're working with, which in this case is B, equals fraction bar, opposite, which is 1, over hypotenuse, which is 4. Okay. And you'll notice here that unlike the other problem, I don't know what the angle measure is here. So now I don't have the ability to use my calculator to figure out what the sine of a number is. This is sine of B, my unknown is existing here. So when I know what the sine equals, but I don't know what the angle is, I'm using what's called the inverse sine, and that's the way it looks. So here's how it works. Sine of unknown equals a number. All right, so we know the number, we don't know the angle. The angle equals inverse sine of whatever that number is. If this said tangent of B equals 1/4, this would say B equals tangent negative 1 of 1/4. If this said cosine of B is equal to 1/4, this would say B equals cosine negative 1 of 1/4. Now that's called the inverse sine. On a regular calculator, it's typically located right above the sine function. You can see sine, right above it, sine negative 1. Okay? I'm going to access it by hitting the second button, hit sine negative 1. I type in 1/4, hit end parentheses. It tells me what angle measure gets me a sine of 0.25, which in this case is 14.47. Let's go 14.5. Using Google, here's my Google calculator again, and once you type in a question of that type, it pops up on the calculator there. You'll see right there it's INV. So you type in INV sine of 1/4 equals, and it spits out the same answer. You notice it's called arc sine here. That's the official mathematical name for it, but again, it's inverse sine. It means the same thing. So you hit the inverse, then sine, it'll say arc sine, and then up 1/4, and it gets you the same answer. So 14.5 degrees. Let's just go 1 decimal place on final answers for now. So let's just say that's fine, 14.5 degrees. If I want to find angle A, I can do it one of 2 ways. I can erase all this work here. Let me just erase all this. So if I'm looking at angle A, I go across, that's the opposite side. Here's my right angle, I go across from that, that's my hypotenuse, which makes 1 the adjacent side. Going back to SOHCAHTOA, maybe. We'll see in this specific case, I'm trying to find angle A. I don't know angle A. I know the adjacent measure is 1, the hypotenuse is 4. So I know the hypotenuse, I know that, I know the adjacent, I know those. This only has 1, no good. This only has 1, no good. This has 2, so it's good. That leads me then to C for cosine of A, the angle I'm working with, equals fraction bar. And we get adjacent, which is 1, over hypotenuse, which is 4. The sine of B is also the cosine of A. It doesn't really matter as far as how you do it, but that's just the information I'm getting from the problem here. If cosine of A is 1/4, that means A is equal to cosine inverse of 1/4. And again, our calculator knows the answer to that. If we just go to it, we type in inverse cosine 1/4. It tells me 75.5. Or if I go to my Google, I type in inverse cosine 1/4. It equals 75.5. So again, use the tools you have at your house. So A is equal to 75.5 degrees. So that is a technique for finding it. The other technique for finding it, so now we got both answers, but once we knew what B equaled, keep in mind that A plus B plus C equals 180, right? So A, which is what we didn't know, plus B, which is 14.5, plus C, which is 90, is equal to 180. Once you get two angles of the triangle, you can always use just basic subtraction to find the other angle. So So 90 plus 14.5 is 104.5. We slide that over, subtract. And if we subtract 180 minus 104.5, we're going to get 75.5. My writing is atrocious today. 75.5 degrees. Both methods work. The advantage of doing that is you get extra practice in the technique. The advantage of this is it's easier. So kind of leave it up to your own abilities. If you're getting this really well and you don't feel like you need the extra practice, feel free to use the easier technique. If you want the extra practice, maybe check with that just to verify you're doing it right. That might be a good plan. All in all, you want to practice the skills to get better at it.